So I'm Doris Folini from the Institute of Atmospheric Science and Climate Science of ETH Zurich, and I present some work on behalf of this institute and of the Center of Climate System Modeling at ETH. Our basic interest is to understand how the climate on Earth functions, what are relevant processes taking place, and how human beings or natural changes affect the climate system. So what we concentrate here is the effect of aerosol particles. That can be dust from a desert, it can be soot particles from fossil fuel combustions when you run the car or so. What's the effect of such particles on climate? On an everyday experience level, if you have lots of dust in the air, sunlight gets dimmed, the sun isn't as bright at the surface where we live as it is in clear air, so you have less energy down here, it gets cooler, and you evaporate, for example, humidity less efficiently, so you get less water up in the air. So the effect of dust and aerosol particles in the air is to change temperatures. It has an effect on precipitation, and we try to quantify this with global climate modeling. More concretely shown here is if you compare an atmospheric state 100, 200 years ago, where human beings had less influence, we didn't have that many cars and heatings and so on, as compared to today. Our models say that we experience some reduction from precipitation. we have less rain today than we would have in a cleaner atmosphere, say our model results. And some of the warming we see, we measure these days, would even be more pronounced if we hadn't a cooling effect of the aerosols, that aerosols block some of the sunlight already a bit further up. So that's about the research we have on the poster.